Not very many people are good at it.
Yep.
Can I get a drink of water?
Be really quick. All right. So we're going on to chapter 13 in the old book. This book doesn't have a chapter 13. They have a chapter 12, and it's so horrendously written. I mean, the problems were so hard that even I was confused. And I said, why would I put sophomores and freshmen and juniors in high school through this when they don't have to go through this? So I'm not making you go through that. I'm going through an older book, which is so much more, you can get it easier. So this first section is on experimental and theoretical probability. What are the chances something's going to happen? That's probability. So you find an old clock in your attic. The hour hand is broken off. Between 12 and 2, how many positions are possible for the hour hand? For a 12-hour period, how many positions are possible for the hour hand? What's the probability the clock stops somewhere in between 12 and 2? Okay, so for a 12-hour period, let's say the hour hand is just on a number. We won't count when it's in between numbers. When it's just on a number, just on a number, just on a number. How many positions is that in that 12-hour period? There's 12. How many degrees are in a circle? 360. So basically 360 divided by 12 is 30 degrees. So every 30 degrees, you basically have a number. Now, how many degrees are in between 12 and 2? Between 12 and 2. There's 60 degrees out of 360 degrees in a circle, which is 1/6 of the time. Okay? So the probability that the clock stops somewhere in between 12 and 2 is 1/6 of the time. Okay? All right. So, words. An outcome is the result of an experiment that you do. Okay? It's the result of a situation or experiment. An event might be a single outcome, or it could be a group of outcomes. Okay? So you could have, if this happens, what's the probability of this, this, and this? That's an event. Okay? An outcome is a single thing that happens. An event could have multiple outcomes. Okay? The set of all possible outcomes is a sample space. Okay? So the probability of an event is the number of favorable outcomes over the total number of outcomes. So it's the probability over the total number. Okay? So the probability of something happening is going to be a decimal number somewhere in between 0 and 1. It's less likely to happen when it's 0. It's more likely to happen the closer it is to 1. So there's a difference between experimental probability and theoretical probability. Experimental probability is like I roll a die. Okay? How many sides are there on a die? 6. So let's say I roll a 1, a 2, a 3, a 3, and a 6. Okay? I rolled the die how many times? 6 times. Okay? So experimentally, I got a 1 twice. I got a 3 twice. So the probability of getting a 1 would be 2 out of 6. The probability of getting a 3 would be 2 out of 6. Now that's experimentally. Theoretically, what's the probability of rolling a 1? 1 out of 6. A 2 is 1 out of 6. A 3 is 1 out of 6. Okay? Those would all be 1 out of 6. But if you do an experiment, then sometimes it's not the same as the theoretical probability. Okay? So, let's look at this. Quality control inspector samples 500 LCD monitors and finds defects in 3 of them. What is the experimental probability that it'll have a defect? Well, it'll be 3 out of 500. Experimentally, he finds that 3 out of every 500 are defective. Now, is that going to happen that way the whole time? No. That's just what he tested and so on. So if they produce 15,240 monitors in a month, what's the probability that they're going to have a defect? Well, this is 0.006 or 0.6%. So you take that 0.0606 times the number of monitors, 15,240, and about 91 monitors will have a defect. Okay? Let's say a park has 538 trees in it. You choose 40 at random and determine 25 are maple trees. So 25 out of the 40 are maple trees. Somebody with a calculator, take 25 divided by 40. I think it's 0.625, right? .625. So if there are 538 trees in the park, if we take 0.625 times 538 trees, we can find about how many trees are maple trees. So what's 0.625 times 538? 336 point what? So about 336 of them are maple trees. Okay? About. That's not exactly, but that would be about. Now, theoretical probability is using math to determine the probability of something happening. Like a die. A standard number cube is a die. Okay? 1 through 6. No number is used twice. So the experimental probability is you've got, if we just look at, if you roll it once, you got 1 chance to roll a 1, 1 chance to roll a 2, 1 chance to roll a 3, 1 chance to roll a 4, 1 chance to roll a 5, and 1 chance to roll a 6. Now, if you roll 2 of them, the probability of having a sum of 2, 1 plus 1, you got 1 chance out of these 36 chances. The probability of rolling a sum of 3 is 2 chances out of this 36. Probability of rolling a 4 is 3 chances out of 36. The probability of rolling a 5 is 4 chances out of 36. The probability of rolling a 6 is 5 chances out of 36. The probability of rolling a 7 is 6 chances out of 36. And 8 is back down to 5 out of 36. 9, 10, 11, and 12. So the probability of rolling a 12 is you got 1 chance out of 36. Okay? And so on. So this, if you make out a chart like this, this can help you figure out what the chances are. So what's the probability of rolling a sum of 9? If you have 2 dice and you roll them, what's the probability of getting a sum of 9? 4 out of 36, which is a 1 out of 9 chance. What's the probability of rolling 2? 1 out of 36, because there's only 1 chance. What about a 13? 0 out of 36, which is a 0 chance because you can't add up to 13 on die. Okay. All right. The complement of an event is the probability of an event not happening. So let's say we have a 36% chance of rain today. So what's a percent chance of no rain? a 64% chance. This is the complement of this. The complement is whatever is left over, okay? So you just subtract, okay? So the probability of the event plus the probability of the not event should add up to 100% probability. So the complement is, what is it not? Well, you take 1 minus it happening, okay? So let us now jump to this and look at some of the homework problems you'll see. All right, how many in this top one, how many red squares do you, or red shapes do you see? 3. How many total shapes are there? Probability of red is 3 out of 8. How many numbers are not less than 4 here? Not less than 4. Ooh. Go with Molly. She said 5. Because is 4 less than 4? No, so 4 counts, and then 5, then 6, then 7, then 8. So there's 5 out of the 8 that are not less than 4. Okay? Out of 160 workers, 23 walk to work. What's the experimental probability that you're going to walk to work? Well, 23 out of 160, which if we turn it into a decimal is what? Let's round it to 2 decimal places. What's 23 divided by 160, Grace? What? 0.14. Okay. So if we take that 0.14 times 4,100 now, we figure out, okay, about out of the 4,100 workers that work there, about how many are going to walk to work? What? 574. So it says round to the nearest 10. So about 570 workers are going to walk to work. Okay. Georgia. How many letters are in the state of Georgia? 7 letters. How many I's are there? So there's a 1 out of 7 chance if you put all the letters of Georgia in a bag and you pull one out, you're going to pull out an I. All right. So you're going to toss a coin 3 times. What's the sample space? Here's what a sample space is. And now this gets a little complicated. So on the first coin that you toss, it's either heads or tails. On the second coin you toss, it's either heads or tails, right? So if you're tossing 2 coins, you could get a heads and a heads and a tails and a heads, or a tails and a tails. So there's 4 outcomes possible with tossing a coin twice. If you toss it a third time, which we're doing, each one will have a heads and a tails coming off of there. So you could have, and then this is what the sample space is. You could have a heads, heads, heads going through the top. You could have a heads, heads, tails. You could have a heads, tails, heads. And yes, you have to type all this out on the, or you have to write all this out on your worksheet. Heads, tails, tails. Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads. And then tails, tails, tails. Okay? So, what's a probability of tossing at least 2 heads? Is there at least 2 heads here? Yeah, there's 3, so at least 2. There's, you know, that works. So there's 1, 2, 3, 4. So 4 out of the 8. Simplify your answer. So half the time you should be able to toss 2 heads out of the 3. 2 of the 3 should be heads. All right, a music collection. 18 rock CDs, 12 country CDs, 7 classical CDs, 5 hip-hop CDs. When you add 18, 12, 7, and 5, you should get what? 42 total. What's the probability of selecting a classical one? Well, there's 7 out of the 42. Simplify your answer. That's a 1 out of 6 shot. Probability that it's not classical. Well, if there's 7 that are classical, how many are left that are not classical? 35 out of 42, which is 5/6. The weather report shows 41% chance it'll rain tomorrow. What's the percent chance it won't rain tomorrow? 59. It says write a decimal answer, so that would be 0.59. Doesn't say to write it as a percent. Okay? Here's experimental probability again. From 16,000 graphing calculators, they take a sample of 825 of them and find 6 are defective. So 6 of the 825 are defective. So if we multiply that times 16,000, we can find the number of calculators that are defective. So instead of turning this into a decimal and then writing down the decimal, clearing your calculator and putting that decimal back in, just take this divided by this times this, and you'll get the right answer. Otherwise, you might get a rounding error if you just round. So if you round to the nearest whole number, about how many are defective? 155 defective calculators. Out of the last 60 people who went through the cash register at a department store, 10 were blondes, 15 were black hair, 27 were brown hair, and 8 had red hair. Probability of being a blonde is 10 out of 60, which is 1/6. Finally, 100 people are asked about college. What's the probability that they will not go to a 4-year college? Well, 43 go to a 4-year college. What's the probability that they won't go to a 4-year college? How many are not going to 4-year college? 57 won't go out of the 100, and that's a simplified fraction. Okay? So those are the types of problems you'll see on your worksheet. Only one worksheet today, so we aren't going to be super busy today. So don't be mad about that.